Number 6. The charge entering a certain element is shown in figure 1.23. Find the current at, and then they want you to find the current at 3 points, and so that's the figure there. So the charge entering a certain element is shown in the figure. I sort of blanked out there. I'm in a very small room, enclosed. There's no ventilation. Dry erase markers. It's not great. Find the current at 1 millisecond. All right. So I wonder if kind of just scooch them on over. So the time units are in milliseconds. I wonder if we can just do this right here. We want the current, right? Yeah, we want the current. So we want the current. So remember, I is dq by dt, which means we're after the slope. So also notice the charge is in millicoulombs, the time is in milliseconds. So since they're both milli, you'll end up with amps. Let's take a look at that. Come on, there we go. Okay, so if you had like 10 coulombs divided by 2 milliseconds, I say that's 5 amps. But you say, how do you know? Because they're millis. Well, we can change them. 10 millicoulombs over 2 milliseconds. 10 millicoulombs is the same thing as 0.01 coulombs. 2 milliseconds is the same thing as 0.002 seconds. And then if you don't want to get a calculator out, what you can do is you can say, well, I'll multiply the top and bottom by 100 in order to get this decimal place on top moved over and not change the value. So this 100 moves that decimal place over. This one moves this one over, and that gets us 1 over 0.2. You can always move it over again. 10, 10, 10 over 20, which is, no, sorry, not 20. I was like, hang on, that's not right. 10 over 2, which is 5. So there you go. So what we learned then is make sure everything is in your SI units. And I know I like to say, put them in your standard SI units, which would be coulombs and seconds. But as long as the prefixes all match as well, then you're good. But if you're ever in doubt, put them all in the regular. All right, let's try to see if we can get that back up. So what is the current at 1 millisecond? Well, 1 millisecond, we're right there in between. Oh, come on, where are you at? There he is. We're right there in between. Can I make this a little smaller? There we go. So we're right there in between the 0 and the 2. So that means it's the slope of this straight line in there. So we just need to find the slope of that. Not too bad, I think. I think we can probably do that. Remember how to find the slope of a straight line, right? You just need points at either end, and we see that on the top end, it's 30. And then at the bottom, it's 0, minus 0. And then we have 2 and 0 milliseconds. So the slope is 15 amps. B, 6 milliseconds. So 6 milliseconds. What is the current at 6 milliseconds? Oh, well, the slope is 0. 0 amps. Slope is 0, right up there. See? Doop. Same amount of charge, 0 slope. Yeah, we're finding the current, right? Yeah. Okay, so 10 milliseconds. Okay, same thing. We're over here, and we're going to have the slope of the down spot. So we have 0 minus 30 divided by 12 minus 8. 8? Yeah, 8. Yeah, okay. That's minus 30 over 4. And then that's 7 would be 28. And then you have 2 left over. So 7.5, 7.5 minus 7.5 amps. Is that right? No, I don't have my calculator. Oh no! That's okay. I'm on a computer, and you would think a computer can do it, right? Let me just do this real quick. 30 over 4, yeah, 7.5. Haha, look at that. All right, and yeah, that's it.